My name is Matt McLoughlin. Just want to say welcome to my talk. Firstly, I want to check you're all in the right room because there seems to be an awful lot of you. And I'm pretty certain some of you might have it wrong. But anyway, I should also say welcome to NDC, seeing as I'm the first talk. For those of you who haven't been to this conference before, I've been, I think, the last 4 or 5 years now. Had the privilege of speaking a few times, and it's a brilliant conference. So hopefully the next few days you're going to learn a lot of new stuff. And by Friday, you'll be absolutely knackered and brain fried, but it's a good thing because you're learning lots of stuff. So my talk's titled Thinking in Events. Before I get started, there's a couple of things that I want to cover. Firstly, I'd like to thank NDC for not putting me on one of those crazy stages that you see around the building at the moment, where the stage actually hangs above the ground on these big chains. If you ever stood on one of these things, they do wobble a little bit, and it's a little bit disconcerting. You're expecting it to drop at any moment. So thank you for putting me on a nice stable stage, although there are some cables I'm probably going to trip up over. Secondly, this is the second talk that I've done where I've used my Surface Book. I bought this Surface Book in January, and it brought out the inner artist in me, because you've got a pen, you can draw all your slides. It turns out my inner artist is pretty bad. It also turns out my spelling is atrocious, and my handwriting's atrocious. So I've done all these slides now. Hopefully there's not too many spelling mistakes, and hopefully you can read them. But with all that in mind, my talk, Thinking in Events. So, excuse me. Why this talk? Why did I want to give this talk? So I've been working in domain-driven design for about 4 or 5 years now, and this concept within domain-driven design of the event. It's not directly linked, but it gets talked about a lot. And this event is a very simple concept. The idea of an event is a very simple concept, but it's very clever, and it's really useful for helping you design your application, for figuring out how your application works, and it's also incredibly useful for helping you build your application, and it can change the way that you architect your code. So I just wanted to give a talk that goes back to the basics of an event and points out and highlights some of the benefits that it can bring you when you're going through this process of working on an application. The things that we're going to be covering, so like I say, I want to talk a little bit about how this idea of event can help the way that you design your application. It can help you understand the application you're building better, and it can help you work with your domain experts better. So I want to talk a little bit about that. I'll then define what an event really is. And then I want to talk a little bit about how this idea of an event can change the way that you write your code. And at the end, I'll talk a little bit more about some of the other benefits that this idea of an event will bring. But what I want to do is I want to start off actually by talking about where I see a problem with the way we currently write applications. And this is a problem that I hope events will fix. The domain that I'm talking about, so I used to work for a hospital in the north of England, an NHS hospital called Leeds Teaching Hospital. And whilst I was working there, we had this idea of something called an encounter. Now, it's a pretty simple concept, and basically, an encounter is the thing that is responsible for I'm getting very close to the edge, aren't I? I'll step back in a little bit. That would be disastrous. The idea of an encounter is it's the thing that's responsible for tracking a patient's movement through the hospital. So when a patient gets admitted, it's the encounter that deals with that. When they get transferred to a different ward, it's the encounter again is the thing that deals with that. And finally, and hopefully, when they get discharged, again, it's the encounter that deals with that. So it's only a very simple problem. Hospitals in general are an absolute minefield of. It's an incredibly complex field to be working in, but this is only a very simple problem that I want to talk about. But hopefully I can use it well enough to demonstrate some of the points I want to make. So, like I say, let's start talking about the problems I see with web applications. So, with applications in general, sorry. So, imagine the scenario, okay? See, inner artist. God, I'm bad. This is a little stick man. I'm going to call him Adam. Adam Stickman. Adam Stickman is on his way to hospital because he's got something wrong with him. Now, the first thing that happens when you go to hospital is, if you're in the NHS, you wait for a very long time. like 4 or 5 hours before anybody even realizes you're there. But you'll end up speaking to a doctor. He's a doctor, he's got a stethoscope, that's a proof. And this doctor will be responsible, or a nurse will be responsible for admitting you to the hospital. Now, when we admit you to the hospital, they need to record this somewhere, right? And this is where us as software engineers come in and we build these applications so that they can record this information. And generally what we'll do is we'll go, all right, it's a new patient, let's create a patient, okay? So we have some code, it creates a patient. Then that's fine. Now, it turns out that Mr. Stickman here, he's not so well. Mr. Stickman's not well, you can tell by the unhappy face. And he gets moved to a ward, so there's a transfer happening here. So again, in this situation, we need some software that will manage recording this transfer. So what will we do? Well, we go, right, okay, so we'll update the patient record. He's now gone from Ward A to Ward B, Ward 10 to Ward 74, or whatever it is, and we need to record that information. Then, if all's well, Mr. Stickman gets to leave the hospital. He's all right, everything's fine, but excuse me, again, we need to record this information. So we do the same thing as we did before, and we update the patient record, right? Now, this is wrong for a number of reasons. Firstly, when you come to writing a code like this, and you can all see where this is going, it's an update method. This is in a service layer somewhere, and we always try and handle too much in these update methods. You'll always find them like 100 lines long, and we're all trying to deal with multiple different situations. But that's not the only problem. The other problem is this isn't how people think, right? We as software developers, or me personally in my early career especially, we would be taking these, what are actually real-world events, things that are happening in the real world, and we'd be taking them, and we'd be trying to convert them to these update statements, to these create statements. And there's a disparity between this. It's not one-to-one, it doesn't make sense. And it gets worse than that as well, because it's not just us that are trying to do this conversion. When we start talking about updating things and creating things and deleting things to the domain experts, to the nurses, to the doctors, we also get them to start thinking in that way as well. And they start going, all right, so you want to create a patient, man, you need to update the patient, man. And that's not how it is in the real world. In the real world, it's events. It's events that are happening to this patient. And these are what we call domain events, right? So these are things that are important to the users of your system. Okay, there's a couple of things to note about events. So, firstly, should always be described in the past tense, which that makes sense because an event is something that's happened. So describing them in the past tense, that's pretty obvious. They should always be expressed using something called a ubiquitous language. Ubiquitous, I think that's right. Whatever. And this is probably something that's actually worthy of its own slide, this idea of a ubiquitous language. Now, this is something else that we do as software developers, where we take what is actually in the real world and we change it to suit our needs. And we change the way that the code is written and we change the language we use. And it's very important that you use the same language that your domain experts use, because then you've not got the ambiguity of what people are saying. I mean, this can be something just as simple as if in the hospital they call it the birth date. So don't change it to a date of birth in your code. Use the language that the domain experts use in your code, and it makes everything a lot easier to understand, especially when you explain what's happening to them. And as I say, it's something that an event is something that your experts care about. Excuse me. So, another thing that happens when you start talking about these events and you start thinking about these events is the way in which you actually think about the entire life cycle of your application changes as well. You go from thinking about updates and creates and continuously changing the state of objects, and you actually start thinking about what happens within your system over time. So if you think about some of the events which we discussed earlier there, or we showed earlier, we've got patient admitted, patient transferred, it might be patient record, survey taken, diagnosis taken, or whatever it is. These are actually events, and you can start to see that and start to think about how that patient goes through the hospital and how it works over time. Which is good, because, again, that's modeling real world. So, where can we use the idea of this event? Now, there's this idea called event storming. It was devised by a guy called Alberto Brandolini 2 or 3 years ago now, maybe even a little bit longer. And the best way to describe it is it's a recipe that he's come up with for organizing a collaborative meeting between you and the domain experts. It's a meeting that's designed to help you figure out what your application should be doing and to help increase your understanding of the domain. And as with any good recipe, it's got some ingredients. So the first ingredient is a roll of paper. Now, I'm well aware now that that actually looks like a roll of toilet paper. Again, not the intention, we're talking like a big sheet of butcher's paper. As much paper as you can get a hold of, okay? And this is going to be your modeling surface. This is going to be where you're actually figuring out how the application is going to work. The next thing you need is a stack of Post-it notes of differing colors. Now, when you actually read about Alberto's stuff, he specifies certain colors for certain things. You can follow his scheme, his key, but ultimately just get as many different colors as you can. And then the last thing you need for this recipe is these guys, the domain experts. So when you set this meeting up, the intention of the meeting is to figure out part of your application, or a large part of your application, or a small part of your application. What you need to make sure is in that meeting is the people who know about it. If the people who know about that part of the system aren't in the meeting, it's not going to be worth any time, because you're just not going to be able to answer any of the questions that you've got. So you need to get the right domain experts and the right engineers in the room. Now, when you've got all these things, you go into a room and you get your paper and you stick it up on the wall, okay? And this, like I say, this is your modeling surface. And the first thing you need to do is you need to get together and you need to decide upon an event, your first event. This can be a number of different things. It can be an important event within your system, or it could be the last event within your system, or the first event. But you need to come up with just one event which everybody agrees on is important. And you put that on a yellow Post-it, okay? Again, just to say, the domain event described in past tense, expressed using a ubiquitous language. This is where the ubiquitous language comes in helpful, because when you're all talking about it together in the same room, there's no confusion. I've even gone to the extent with regards to the language, if there's certain terms, if you're working in a complicated field, actually documenting that language, in a GitHub repository or something is also pretty useful. So you take that event and you put it on your paper. Now this modeling surface, you'll see there's time at the top, so the idea is that these events that happen over time, you model them from left to right, and as more events get put onto the sheet, you should form some sort of order. So once you've got this first event on there, you now need to start thinking about other events. You want to think about the events that lead up to the first event, and you want to think about the events that happen after this event. And you start to pop them on your piece of paper, and you start to build up a bit of a picture of how your application is going to work over time. Now, your system isn't just events. There are other things, and this is where the different colored Post-it notes come into play. So another thing you might want to take into consideration is the command or the action, okay? So this is something that an action that a user might perform that results in generating an event. So in order for a patient to be admitted, somebody has to admit the patient. So these are also useful things to document on the modeling board. Use a blue Post-it note for this, or any color you choose. And you can start attaching these next to the events that they generate. So now you've got your actions, your commands, and your events. Some more things that you might want to think about. External events. Use a purple Post-it note for this, I think. I might have that right. These are parts of your system where you might not necessarily have control over what is happening. It might be an external system, it might be another team within your business that you might not necessarily be able to do anything with their software. It might be some legacy stuff. These are still important events that might relate to your domain, so you need to put these on the board as well. Things under your control. In the case here, admission from ADT. So in the hospital, ADT stands for admission, discharge, and transfers. It's another application that can also admit patients to the hospital. So it's possible we could get an admission not only from user interaction, but from a different system. And then you put those boards on, put it on the board as well. Again, starting to build up a picture of how your system works over time. Another thing to consider is read models, or in DDD, they're more often known as projections. This is your views of the data. These are the things that your users want to be able to gather information from. It's also where you might get information from in order to execute a command. Also important to the system, you can put these up on the board as well. Now the next one's relatively important, and that's questions. So at the start I said you need to gather all the people that are relevant to that domain in the same room so that you can answer all the questions. But it might be that the right person is actually not in the room. You don't know where this modeling process is going to go. So if the right person isn't in the room, you could get stuck on a given point. Now, normally what happens in meetings, or at least I find in meetings, is when there's a point of contention or something that's not understood, rather than trying to get that guy in a room or postponing it, what happens is two people who don't really know what's going on will then attempt to try and figure it out themselves. And they'll make a lot of instinctive guesses about what could happen, and we'll probably get it wrong. So rather than doing that, just write a question on a post-it note and stick it up on the board. Now, it might also be that you don't have all the relevant information as well. So it's not just about one person. The system, don't knock that out. The system might not be in the right state to make the decision. Now, when you put these on the board, you'll start to notice something, and this is why it's good that it's visual, is that there's certain parts of your application that might be more problematic than others. And you might not know what these are going in, but once you start speaking to the domain experts and all these questions start coming up, you'll notice it will probably all correlate around a given event or a given part of a system. As you can see here, as I poorly demonstrated with my drawings, all the events are kind of the questions are grouping around the top left-hand corner. So even without knowing what the questions are, you can tell that that's probably a problematic area within the software. So you can then go and drill into that at a later point or focus on that in a different meeting, but it highlights it there for you. Now, just to give an example, to actually some real-world events in there that you might see. So you've got an admit patient command there that generates a patient admitted event. You've got the question where we transfer a couple of word views. And it really helps building up a good view and collaborating. Now, a couple of tips for running this meeting. So the first one is you need lots of space. When I say lots of space, I'm talking about modeling space. There's no point going in there with a couple of A1 sheets of paper, sticking them up on the wall, because if you run out of space, then it becomes difficult to run a meeting. So it makes sense to put up as much paper as you can. Just sprawl it all across the walls and give everybody the opportunity to work on it. The next point is no chairs. Get rid of the chairs. Because if you leave chairs in a room, it gives people the opportunity to do what I do, which is go and sit down in the corner at the back, and you kind of go, oh, I'll let these guys figure it out. If you take away the chairs, they've got no opportunity, they've got no other possibility than to stand up and actually partake in the meeting. And this is important. Okay. Then finally, the other tip is don't let things stall. Like I said about the questions, when people get stuck on a question or they start arguing about how a certain thing should work, it can just completely dominate the meeting. And so often you go into meetings and the aim is to figure out a large part of a system and how you want it to work, and you'll get stuck on that one point. Before you know it, the meeting's done. So just write the question down and stick it up there and come back to it later. You've got to try and keep the flow going. So what are the benefits of this? Well, as I said, it really does help with understanding. It helps you identify where the problems are in your system. It helps you collaborate better with your domain experts and understand exactly what it is they are wanting. It's visual. Now, there's a guy called, I think his name's Dan Rome. I don't know if any of you guys have heard of Dan Rome. No nods or anything. So this is a guy who wrote a book called Back of a Napkin, which is all about how you can use diagrams and things like that to explain your points a bit better. And it's a good book, it's worth reading. And one of the things it goes into is the fact that when you're young, when you're a child, you learn via pictures. That's the primary way that you learn. And then as we get older, we seem to replace this use of pictures with just text, which is a little bit crazy because when you ever look into any scientific reports on this, that better learning is aided by both the use of visual aids and text. So just using text is silly. So when you get these huge functional specs, it's just reams and reams of what you want to happen. It's nowhere near as good as doing something visual. It uncovers problems. As I said, with the questions, you can highlight where the problems are. And hopefully it's fun. As I said, there's nothing worse than when you go into a meeting and you've got this big round table and you all sit around it and somebody says, right, I want it to do this, this, and this. And you sit there and you start checking Twitter and you start falling asleep and you just give up on the meeting, emails, whatever. By forcing people to stand up, to actually interact and work on this board, it really cultivates this want to figure out these problems. And generally, when you come out of these meetings, you don't want to kill yourself, which is a pretty big plus in my opinion. Now, once you've done this event storming process, it's sometimes useful to focus in on a particular command and a particular event in more detail. So we're talking about this kind of relationship. And when I do this, there's four aspects that I like to look at. There's four questions, I guess, that I like to ask about this. And this is, what is the decision that's getting made? What is the information that needs to be provided as part of a decision getting made? What is the result of this decision? And finally, and importantly, when can this decision actually be made? And when you ask these four questions, they're kind of like my guidance for when figuring these things out. You kind of come back with something a little bit like this. So you can say, the decision is to transfer the patient. So you've got your command there. So that's defining your command. The information required is the new ward, the ward where this person's been transferred, and that's the information that you need to provide with part of this command in the code. Then you've got the result, the patient is transferred. That's ultimately the event that gets generated at the back of it. And then at the bottom, when can this decision be made? As long as the patient is admitted. Now, it's only a very simple business rule. Often it's more complicated than that, but that helps you then define the business rules which you want to build into your application. If you do this for a series of commands and a series of events, you'll start to see that certain events are reliant, and certain commands are reliant upon information from each other. And when you get into DDD, there's this whole idea of aggregates and grouping objects together into these aggregates. And knowing which ones are related by asking these questions helps you define that. Or at least I find it helps you define that, because if there's two events are reliant upon the same information, then it's possible they need to be together in the same aggregate. There's more scope about that, but I'll leave that for the course of this talk. So we've now gone ahead and we've used event storming, and we've used it to understand which events are in our system. We've used it to help us understand the system better and to collaborate with domain experts to find out what they want. But the use of those events that you've discovered doesn't need to end there. And you can take those events and you can use them to actually help you build the code and help you figure out how to architect the code. And this is where a subject called event sourcing comes in, or at least in my mind it is. Now, this is an idea that a guy called Greg Young came up with, I don't know, 10 years ago or so. But if you speak to Greg, it's actually a concept that's been around for a very long time in other industries. It's only really in recent years, in, like I say, the past 10 years, when we've started considering these things in software architecture. And it's very basic level. It's just a different way of storing your information. It just so happens to work well with events, hence the name, event sourcing. So if you take this example here, going back to a state-driven application, you can see on the left-hand side we've got a series of events. And on the right-hand side, you can see how we would potentially update the state. Right? So in the first case, we admit the patient, a gentleman called Tony Ferguson. We then transfer the patient to ward 76. We then transfer the patient to ward, again, to 34. And in both times we do that, we just update the record. And then finally, at the end, when we get discharged, you might have a flag in there that says they're no longer admitted in the hospital, and they're not on a ward, so you'd set it to null or something like that. Now, with event sourcing, rather than updating that state, you actually make use of the events that you've discovered as part of the event storming process and take those into a code, and you store those events as opposed to changing the state. So in the case of admitting a patient, we store a patient admitted event. In the case of transferring a patient, we store a patient transferred event. Again, and finally, when we're discharged, a patient discharged event. Again, you'll notice the use of passive tense in the events, and also when we're saving the events, we're only storing information that's relevant to that event rather than constantly saving the entire object. And if you do this for all the objects within your system, you'll start to build up a stream of events of everything that's ever happened in your system since the day of inception. And you'll get something like this, which is an event stream, right? Now, this isn't to do with the domain I've been talking about, but this is a piece of software that Greg has written called Event Store, and it's a persistence mechanism that's designed specifically for storing events. So here you can see this is probably part of a credit check software, so we've got the deal complete, fraud check pass, and things like this, and you get this stream of events of everything that's happened over time. Now, why would you want to do this? Well, we've said that it's a good way of modeling the events that you've discovered within the system, but it's also got some technical reasons which are pretty good. Now, if you consider this situation here, okay, so again, patient admitted, patient transferred, and discharged. If you were just continuously updating the state, then there's a potential that you're going to lose the fact that this patient was currently on a different ward. If you're just updating the ward ID that they're on, once you're onto the second transfer, the first transfer is going to have disappeared and you're never going to have known that's happened. With event sourcing, because you're saving the events, you've always got a record that that thing has happened. Now, there is another way to do that. Who's done this? Has anybody done this before? There's not enough hands up. I'm sure everybody, yeah, okay. Way more people have done this. I've done this. And this is the whole idea that you store the patients in a table, but each time you update that patient record, you take a copy of a row and you insert it in an audit table. If you're using SQL Server, you'll use this thing called database triggers to do this, potentially, which are categorically the worst thing ever, as far as I'm concerned. The amount of times I've been caught out by a database trigger that's hidden away, and so many times I can't even count. So you could do this, but this has got some problems. And one of the big problems with this, there's 3 or 4 big problems with this. The first one is each time you're updating a record, you're saving the entire row. Now, space isn't as much of a premium as it used to be, but it's still possibly something you want to take into consideration. So duplicating the entire row every single time that you just change a ward, it's not necessarily a good thing. Next, you actually have to figure out what has changed. And this normally results in some SQL script that compares one row to its previous row and looks at the differences and tries to figure out what has changed. And that can kind of be a little bit of a tricky thing to do. Also, it's not reliable, especially if you have used database triggers. There's not necessarily a guarantee that this has happened. If somebody deletes the trigger, well, you've got no idea that they've deleted it. And the only time you'll actually find out that it's deleted is when somebody says, yeah, how about that audit? We need to take a look at it. And at that point, it's too late. But the last point, and possibly the most important point when it comes to auditing, is that when you do eventually get audited, and I think everybody is going to go through it at some point with their software, when the auditor looks and they see that something's changed, the first question they're going to ask you is, why has that changed? Okay? And doing it this way, you've got no way of knowing that. I mean, you might be able to interrogate an IIS log, or you might be able to interrogate a transaction log in a database, but you're never really going to know what's happened. With event sourcing, you're storing the event, which is what has happened, and you're storing just the information that has changed. So when it comes to an auditing point of view, it makes it pretty good. Okay. So that's one reason why it's good. And it's all right to say, yeah, it's good, but how does it actually work in practice? So again, going back to the 4 events that we've already talked about, admit, transfer, and discharge patient. Now, it's all right saving those events, but ultimately you still need to know the state of that object if you want to apply any business rules to it or you want to check anything about it. So the way it works is when the first event comes in or when the first command gets executed, admit patient, that's a pretty simple one. The object doesn't exist yet, so we just generate a patient admitted event. When it comes to transferring the patient, well, we need to know if the patient's already admitted. In order to figure that out, we take that patient admitted event and we replay it against the object. When we've done that, we'll have it in its current state and we can check to see whether we can transfer it. And if it's successful, then we can save away the patient transfer event. Transfer the patient again. So in this case, you need to replay the patient admitted event, replay the patient transferred event, and then finish off by attempting to apply the patient transferred event, the second patient transferred event. And finally, when it comes to discharging the patient, you replay the first 3 events and then attempt to discharge a patient. So that's how you get it to its current state. Now, this does have a couple of problems, and it might be pretty obvious. That is, if every time you're wanting to use this object, you have to replay every event that's ever been saved against it, you have to replay all these events, and it can take quite a long time. Well, no, realistically, it doesn't take a long time. If you've got an object that's only got maybe like 100 events saved against it, you'd be surprised how quickly, depending on complexity, you can replay those events to get to the current state. But if your object does have a lot of events against it, you can use something called the memento pattern or a snapshot pattern, depending on what you want to call it. And this is the idea that every X number of events, you actually take the state of that object and you save it away. Okay? Now, what that then means is when you want to rebuild this object, you don't have to replay all the events. You can just take the last state and then replay all the events that have happened after that state was taken. It makes it a lot quicker. So that covers pulling out these objects in order to be able to change the object or be able to execute a command against it. But what it doesn't take into consideration is the possibility that you might want to aggregate a number of encounters together. So we saw on one of the previous event storming screens that one of the things they wanted to see was a ward view. Now, if we were going to use this technique in order to generate a ward view, we would have to get all the encounters, we'd have to replay all the events that those encounters have got against it. You'd then have to aggregate that data together into some kind of ward view, and then you'd have to return that to the user. And that could take a long time. That's where it really does fall down. But it's also where this idea of CQRS comes in. Now, CQRS is an extension upon an idea from a guy called Bertrand Meyer, who came up with this idea, this thing called CQS, which stands for Command Query Separation. And this was the idea that a method should only ever be responsible, a function should only ever be responsible for either performing an action or returning a query. It should never do both. And that makes a lot of sense, because if you've got a method that returns data, but at the same time it modifies it, then you're going to end up in a world of hate, especially if this is something that's hidden behind a third-party API. Debugging what's going on is going to be a nightmare, so it makes sense to keep them separate. CQRS, Command Query Responsibility Separation, stands for, takes it one step further, and it says, well, we want a different object for our writes, and we want a different object for our reads. And in the case of event sourcing, that makes sense, because you've got this model which is good for writing. It stores all your events, which are incredibly useful, but it's not very good for reading. So it makes sense to have a different model. Now, if you've ever used SQL Server and you've kind of used Entity Framework to write to the database, but you've used something like an SQL view to read from a database, that could be considered CQRS in one respect, because that's two different models. Now, it turns out that these events are actually really good at generating these read models, because there's no reason you can't have a mechanism within your code that says, well, when I see these events, I want to use them to update a static view. So when I see the patient admitted event, there's no reason why I can't say, well, I want to take that event and use it to insert a row in a table. When I see the patient transferred event, I want to use it to update a row. Again, second transfer, update the row again, just toward. And then finally, when it comes to discharging the patient, when we see the patient discharge event, we can just delete the row from the table. We don't have to do a soft delete or anything like this because we've got a record that the delete happened in the event store. This is just purely for read, from a read point of view. So you can remove that row completely. So now you've got your event stream and you've got them generating a model that's suitable for reading. And when you start thinking about separating your write model from your read model, there's no reason you can't take this a step further and say, well, why can't I have multiple read models? Well, you can. There's no reason why when you see the patient admitted event, but you can't use that to update a ward view, you can't use it to update a demographics view. And again, this is something that's an incredibly powerful technique because it brings a number of advantages. The first one is, if you get a bug in your ward view for whatever reason, for some reason somebody's written some bad code, probably me, but if somebody's written some bad code, what you can do is you can delete that ward view completely, you can fix a bug, and then you can take all the events that have happened within your system and just replay them against it since the beginning of time, and your ward view will come back up to date eventually, and the fix will be in there. Another advantage is that occasionally you get asked the request of, I can see the ward view now, but what was it like last week? And in that situation, just create a new copy of a ward view, but this time only replay the events against it up until last week. And then you'll have an exact representation of how it looked last week. And finally, and this one saved my bacon a few times, is adding, for example, reports to the system after it's already in production. Now, in this case, imagine a situation where the ward view's been created, it's been in production for 6 months, and the boss comes along and says he wants the demographics view. Well, in that situation, you can create the demographics projection, you can listen to the patient admitted event, you can bring it online and you can replay all the events against it, and it will be as if that view was there since the beginning of time. And it's dead simple to do that. Is this talk going to finish at 20 past? Is that right? Yeah. Okay. So that's kind of how the two work together. I just want to talk a little bit about the architecture. So there's multiple derivatives of this, and you'll see this, but you'll see this kind of diagram quite a lot. People change it a little bit and do it in slightly different ways, but this is kind of your quintessential base level architecture, where you'll have a client at the top. This client will take a command and it will give it to the dispatcher, which will interact with the domain, resulting in some events being saved. Those events will then be put into the event store and read by the projection manager. Now, one of the two terms I really hate in software development are manager and service. They don't do anything to explain what's going on, but in this case, I think it's okay. Everything's a service, right? Everything. So this projection manager will be responsible for giving the event to the correct projections, and that in turn will populate the read model, which can then be viewed by the client. To go into it in a little bit more detail, this is the start of a pipeline. So when we see an admit patient command, this is a common pattern that you'll see a lot. Basically, give that admit patient command to a dispatcher. That dispatcher will then be responsible for figuring out which piece of code needs to handle that command. If you've seen the mediator pattern, the mediator library by Jimmy Bogard, that kind of does this thing. What it looks like in code, it's a C#, but what it looks like in code eventually is, you can see at the top, you create the patient admit command, you then dispatch it. The dispatcher is responsible for figuring out which handler it needs to use to execute it, and then it gives the command to the handler. The handler itself creates a new encounter and saves it away. The next step is actually within the encounter object. So we admit handler calls into the encounter object. Now, this encounter object is responsible for a number of different things. It's responsible for 3 things. First is a list of events. So it needs to be able to keep track of which new events have been generated so they can be then saved to the database. It needs to be able to keep track of its version, which I'll talk about in a second. And lastly, it needs to be able to apply events. So this is what I was talking about when, in order to get the object to its current state, you take all the events that have happened and you apply it against the object, and eventually it will end up in its final state. The reason for the version is to do with concurrency. And this is, if you've got 2 people that both want to access the same encounter, one pulls it out at version 5, the other one pulls it out at version 5. First person generates a new event, and it's now at version 6. When it saves it to the database goes, oh, it's version 6, cool, you can save it. The second person tries to do the same thing and save version 6, but now it's version 7, so it goes, no, screw you, can't have it, throw an error, return it back to the customer, get them to resubmit it, or some other business rules can take care of that situation. In code, it ends up looking a little something like this. So this is the constructor of the encounter, so passing in the information that's required. We generate a new patient admitted event and raise it. So when we call the raise method, this is responsible for storing that event in that collection of new events, and it's also responsible for calling into the correct when method, and then the when method applies it to the actual object. The reason these 2 are separate is because, like I say, you need the ability to replay, and when you replay, it just calls these when methods. And then this is the last bit of the puzzle, which is the projection manager. So we've now got this patient admitted event. That gets given to projection manager, which, not dissimilar to how the command dispatcher works, it takes that event and it figures out which projections care about it. And it gives it that event, and they can then go and do whatever they like with it, such as update a ward view. Again, there's an important thing to note here, which is the checkpoint. There's going to come a time when your system goes down every day. And when it goes down, the last thing you want to do is start it up from event 1 again. So in order to prevent that happening, each time you process an event, you store a checkpoint of when that event is, of that event. That means that when you restart it, you can restart from that event as opposed to the beginning. In code, it looks a little something like this. So this is a projection handling an event, the patient admitted event. When it sees it, this was actually done using RavenDB. It opens up a connection to the database, it stores that patient, saves the changes, and then carries on with on its way. Now, if we go back to this diagram, this process can actually take a bit of time, and that can be problematic. So when the client submits a command, they have to wait for it to call into the right domain to rehydrate the object, to attempt to apply the event, save the event. The event has to wait for the projection manager to build up all its projections before it can return a view saying it's successful. And although it can be reasonably quick, it can produce an unresponsive UI. And to get around that, you can actually separate off this section on the right here. You can separate off a projection manager into another process. Because as far as the UI is concerned, as soon as that event's been saved, you can consider that successful. So you can return 200 to the user, and they can go on with their merry way. But it does introduce a problem doing this, which is this word here, or these 2 words here, eventual consistency, these 2 terrifying words. And this is the idea that because your views are being generated in a separate process, there's a possibility that when the user submits that command, the result of it might not be there straight away. Realistically, we're talking seconds, but from a UI perspective, it can look a little bit inconsistent. When you start talking to front-end devs about this stuff, they start getting really ratty because they want the data there straight away. In reality, I don't think it's that big a problem. I mean, there are ways you can deal with this. So one thing you could do is, once the command's been successful, for that user, you could emulate as if it's been successful on a front end, maybe update a table or a view, just for the meanwhile. Or another option is you could generate an event after projections have been completed and use WebSockets or something to return that to the UI, and then they could say, okay, it's there, we can update the view now. In reality, this is only a problem for the actual user that submitted the data. Everybody else who's using the system probably got no idea that this is going on. But it's something to bear in mind. I also think, I talk about this a little bit, but it's almost something we've enforced upon ourselves, that a user now expects that when they do something, that information is going to get propagated all around the world instantly and everybody's going to be able to see what's going on. In reality, it doesn't work like that. Before computers, it definitely didn't work like that because you had to wait for the paper to go down the hallway to a different office. So it's just something to bear in mind. It's something to work around if need be. So that's event sourcing. Now, there's some more advantages that events bring. The diagrams on this are horrendous, so I apologize in advance, but it changes the way that your UI will look. So many of the systems that I've worked on in the past, they all end up looking like some Access application where you've just got streams and streams of pages that have got every single field for that object on them and an update button or a save button or a cancel button at the bottom of it. And applications start looking like that when you start thinking about them as CRUD as opposed to a series of events. So, poor diagram, but you kind of get the idea. When you move to events, this changes and you start thinking more about, I think the proper definition is task-based UIs. And these are UIs that don't necessarily, aren't just a single screen. They're screens that are more context-driven. They only contain the information that's required for whatever you're trying to do, for the action you're trying to perform. And we've got more distinct actions which you want to perform. Instead of just a single update, you'll have buttons for admit, transfer, discharge, and so on and so forth. You can build more of a workflow into your UI, which ultimately ends up with it being a lot more usable than these monolithic screens that have got 100 million fields on it that you have to change one and save and wait. The other advantages that events bring is around testing. So who's heard of given, when, then? Right? So everybody knows what given, when, then is, or assert, arrange, actual, assert, I can't remember what the other one is. With events, it becomes really easy to write tests if you make use of this given, when, then. So rather than updating an object and having to check the entire state of the object after to make sure that nothing's happened, you can write your tests more like this. And here, we're setting up a scenario. We're saying, given these events have already happened, when I try and discharge a patient, then I expect this event to be generated. Okay? And that's it. That's pretty much only the style of test that you'll need to write. Right? You set the system up in a certain fashion, and then you try and execute command and assert a result. And because you're using the events and the tests, and because it's written in such a way that you set up these events beforehand, they're a lot more understandable, and more importantly, they're a lot more understandable to the domain experts as well when you come to talk about which tests you've implemented, because it's using a language that they understand. That okay, when these things have happened, and I try to do this, then this is a result. There's some libraries out there, I can't remember the name of it now, which help you write tests in this fashion. And this is the last advantage I want to talk about, which is communication. I don't know what's happened in the past few years, but this idea of microservices, nanoservices, picoservices, it's everywhere. You can't get away from it. I don't understand it. It's not like it's a new idea, this whole idea of separating services, but all of a sudden now with microservices, let's make them a little bit smaller, and it's suddenly a different thing. Events are a good way of communicating between your services. So these events that you're saving, these events that you've worked out in your system, which make sense to the users, make sense to you, those streams of events you can use to communicate between service A and service B. So when service A performs an action, it generates an event A. Service B can listen to that event and do something with it. Now, there's two ways that you can get these events, move these events between the two services. The first one, which most people have probably heard of, is the message queues, right? MSMQ, RabbitMQ, ZeroMQ, these sort of things. And the idea there is that you have a queue set up in the middle and you put that event on the queue and eventually service B will pick it up. That works well in a number of situations, such as if you need that event to be there immediately. then using a message queue is a better way of doing it. But it does have some disadvantages. Another option is to expose an API of some kind, which basically lists all the events that your system's generated, right? That's another option. That's good because it then means that Service B is in control of the events that are coming out of Service A. So if it, for whatever reason, it needs to go back and look at events that happened 5 years ago, it can do that. With a message queue, that can be a little bit of a tricky thing to handle. The downside of doing it that way is, in order to get the events, you normally have to set up some kind of polling service, and depending upon how important those events are, you might poll every 30 seconds for new events. If that's the situation, you're not going to get your event immediately, and if you need to, then maybe message queues are the best way to go about it. So that's pretty much it, to be honest. There's some resources that I want to point out. So the event storming that I talked about at the start of the talk, this is a book that Alberto's writing. It's on LeanPub. At the moment, I think it's about 70% complete, but there's still a lot of really useful information in there already. Hopefully, he'll complete it over the course of a year. So with LeanPub, I think you can pay what you like above a certain amount, so it's definitely worth getting hold of that. There's these two books here, which anybody who's done domain-driven design will have read these books and not understood them, and then read them again and not understood them, and then maybe read them a third time and finally got their head around it, okay? So the first one on the left is by Eric Evans, which is kind of the first one to come along, and then Vaughan Vernon wrote another one with the foreword by Eric Evans, which is also another book that's also worth reading. I mentioned this, it is Dan Rome, yeah. I mentioned this book called Back of a Napkin by Dan Rome. It's not directly relating to this, but I genuinely think it's a good book to read, and it will make you want to make a horrendous slide decks with images that nobody can understand, like I did. The code samples that I showed you as part of the explaining the event sourcing, I actually wrote like a small application that demonstrates these points. And one of the things about event sourcing, when people get into it, is they're always convinced that they need to look for a framework or a library that helps them do this. If you actually go and look at that code base, you realize that the actual framework code in order to get a system like this working, it's under a few hundred lines of code. I mean, there's other little bits of security and bits and pieces like that that you might want to add, but there really isn't much to it. So by all means, go have a look at that project and berate me for my coding styles or whatever. And lastly, some links. So there's this DDD event sourcing and CQRS Google group that's been around for a long time now. It's still pretty active. Go on there, ask questions. You'll get answers. I mean, there's people like Greg Young on there. Eric uses it. Alberto uses it. A couple of other guys who are really forerunners in these subjects answer questions on there, so it's a good place to go and ask. We run a channel, a Slack channel. That's for the login for it. We've got like 800 users on there now. It's active every day. We've got rooms for event sourcing, event storming, DDD, even C# stuff, so it's worth going on there. Again, lots of people answering questions every day, so it's another good resource. And finally, the guy who invented event sourcing, Greg Young, has done a really good video there from, I think that's the Coding on the Beach one, which is, again, another great explanation, well, probably a better explanation than me, to be honest, about event sourcing, and he goes into a bit more detail about that. And finally, my Twitter address at the bottom, if you want to heckle me or whatever, by all means try and get hold of me there. And that's about it. So thank you very much. Rather than getting everybody to hang around and wait for questions, if you've got something you want to ask me, you want to come talk to me, just come up afterwards or find me, so I don't keep everybody here and you can go get some food. So thank you very much.